In this podcast, we'll graph a polynomial function showing the correct end behavior and x-intercept behavior. To help me see this graph, I want to first list out all of the x-intercepts. Since x is a factor, that tells me 0 is an x-intercept. It crosses the graph at 0, 0. Since x minus 2 is a factor, that tells me 2 is an x-intercept. It crosses at 2, 0. And x plus 5 is a factor, tells me that negative 5 is an x-intercept. The exponents of each of these factors tell me the multiplicity and whether the graph crosses or touches at each of these. The multiplicity at 0 should be 1, multiplicity of the root at 2 should be 2, and multiplicity at negative 5 should be 1. That's telling us that the graph should cross at the odd multiplicities, and it should touch and bounce back at the even multiplicity. The other part I want to look at is the end behavior. When I look to the far right, as x gets very big, going to infinity, what happens to my equation? Well, my 3x gets positive, my x minus 2 gets positive, and my x plus 5 gets positive. Positive times a positive tells me the function should be going up to positive infinity on the far right. When x goes to negative infinity on the far left, what does my function do? Well, 3x is negative. X minus 2 is a negative thing, but we're squaring it. And x plus 5 becomes negative. So a negative times a negative squared times a negative, that's telling me the original function is in fact going positive on the far left. Putting this together, our x-intercepts and our end behavior, it's going up to the far right. So connecting now to my graph, there is that intercept at 2, but it has even multiplicity, so it bounces back to the same side. The x-intercept at 0, it should cross, and the x-intercept at negative 5 should cross as well. So my graph of this function looks something like this. Again, we're looking for the correct x-intercept behavior and the correct end behavior to see that we're graphing it. It's hard to graph correct y behavior for the y values without having calculus to help us find minimums and maximums.